Here are the solutions to the quiz at the end of lesson 1.2. Now, starting with question 1, we have a uniform electric field, which means constant in size. Therefore, there'll be a force that is constant in size, and that will lead to an acceleration that is constant in size. So that is option number D. Now, question 2, we have a negative charge, minus 3 microcoulombs. We have an electric field that is 2,800 newtons per coulomb. So we know electric field is force per unit of charge, so force is E times Q, which will be 2,800 times 3 by 10 to the minus 6, and we will get 8.4 by 10 to the minus 3 newtons, and the direction will be in the minus y. Now, that was option number C. So question 3, we have a point charge, so we have E is simply K, or 1 over 4 pi E naught, times E over R squared. It will be towards the electron. In other words, it is the direction a positive charge would move, and so that is also option number C. Now for question 4, we have 3 charges. We've got some rough axes here, Y and X. We have one charge here, one there. 2 of them are positive, and the third is negative, and that's A, B, and C. And the question is about the direction of the net force. So let's just look at the net force on each of them. A will feel a force away from B and towards C, which would give a net force roughly in that direction. C will feel a force towards A and towards B, which would give a net force roughly that direction, but B will feel a force away from A and towards C. So that is where the net force would be parallel to the x-axis. So that is option number B. Now, question 5, we have a charge of plus 150 microcoulombs, which is plus 150 by 10 to the minus 6 coulombs. We have R equals 0.2. So the electric field will be 1 over 4 pi E naught Q over R squared. So putting in those values, 2 significant figures, we have 9.0 by 10 to the 9, we have 150 by 10 to the minus 6, we have 0.2 squared, and that gives us an electric field of 3.4 by 10 to the 7 newtons per coulomb, and the directions to the east or to the right of that positive charge, so moving away from it. Now question 6, if we start with 2 charges, we have a minus and a positive. We have a minus 20 millicoulombs, we have a plus 50 millicoulombs. The distance between them, 2.5 by 10 to the minus 2 meters. So at the first we have an attractive force between them, and the size of it will be K Q1 Q2 over R squared. So we have 9 by 10 to the 9 times 20 by 10 to the minus 3 times 50 by 10 to the minus 3, 0.25 squared, and that gives us about 1.4 by 10 to the 10 newtons. Now, if we were to bring them close to each other, touching, then they're going to equally distribute the charge over the surface of both spheres. So the total charge will be the 50 minus 20, so it'll be 30 millicoulombs. But that will be divided between them. So when you pull them apart, each charge will be 15 millicoulombs. So then the force is going to be, just put these new values in, 15 by 10 to the minus 3, and that's just squared over 0.025 squared, and that will be now 3.3 by 10 to the 9 newtons, and now the force will be a repulsive one because they're both positive charge. Now question 7, we have a charge at the top that is positive 4 microcoulombs. We have QA and QB down here. And we're told that the net force is vertically downwards. Now, the only way that can work is if both QA and QB are negative. So you get two forces between them. The other thing we could say is if we're looking at the components here, let's just call this theta, is that if this was FA and if that was FB, this would be FA sine theta, that would be FB sine theta, and we know that they must be equal. So we end up with FA must equal FB, so the size of QA must equal the size of QB. Let's just call it Q then. So each one of these Q's will be contributing a downwards component of force, and that will be F, let's just call it F here, cos theta. So the net force is going to be F cos theta, which is the vertical component of each one, times 2. So let's work out what the size of that would be. K, Q being the Q up the top, times, let's just call it A, we know B is equal, times cos 30, and we have R squared. We times it by 2, and that is going to equal 405 newtons. So then we get QA, if we just do some rearranging, 405, R, which is 0.02 squared. We have 2, 8.99 by 10 to the 9, 4 by 10 to the minus 6, times cos 30, and we end up with QA, which is equal to QB, will be minus 2.6 microcoulombs.